Hello friends, welcome to Shiksharthi. In this video, we shall be talking about percentages, and under the head of percentages, we'll be doing simple interest and compound interest. So let's start. Now, the prerequisite for this video is that you should have seen my earlier videos on percentages, because in that case, we have discussed quite many points on simple interest and compound interest as well. So you are expected to watch those videos first before you see this explicit video on simple interest and compound interest. Okay, going forward, now whenever I am talking about P, I am talking about principal amount. T is the amount due after T years. R is the rate of interest per annum or per a given time period. I is the interest. T is the time period of investment for further discussions. And we shall be dividing this video into two parts. So this being the very first part. Okay. So now the very first thing, if you recollect the discussion that I have had earlier in my video on percentages, try and relate with that. Now when I say try and relate with that, if you recollect, the very first point that I had talked about in the concepts on percentages was the change in value is given by the final value minus the original value. So now here the change in value is nothing but the interest part, right? The change in value is nothing but the interest part. So if I say interest, it is nothing but the amount minus the principal, where what is the amount? A is the amount due after T years is nothing but the final value. Now this is, what is final value? Final value of the investment done. And what is the final value of the investment done? The investment done would be the original value, and the original value here will be the principal amount, which is made available for the sake of investment. I hope this part is clear. So rearranging that formula, the final value becomes how much? The final value becomes the original value plus the change in value. So we know now that the final value is the amount due after T years is equal to what? The final, so amount is nothing but the final value. P, principal value, is the original value. R. So now in this case, we'll be able to say that the amount due after T years will be nothing but the final value. The final value, which is the amount due after T years, is nothing but equal to the original value, which is the principal amount of investment, plus the change in value, which is the interest. Please try and relate it with the earlier discussion on percentages. Okay, so now you would see that here I have divided this into two sections broadly. So this being the compounded interest section, this being the simple interest section. Now as discussed earlier, simple interest is as simple as understanding it as a single change. And we know that for a change we require for a change, that means we are talking about one change, we require exactly two entities. And what is compound interest? The compound interest is nothing but, let's put it like this, at least two changes or three or more changes, right? So when I say at least two changes, that means I am basically talking about this being the first change, this being the second change, and thereafter. So now if I have to deduce the formula from the earlier formulas that we have already discussed in percentages, so we will deduce it like the final value divided by the original value is nothing but the rate of changes expressed in the fractional format and thereafter multiplied by each other. This formula is not new. We have discussed this formula earlier also. All we are doing it, we are tweaking it with respect to simple interest and compound interest. So for the sake of compound interest, this becomes final value is the amount due after T years, and the original value is nothing but the principal amount which was made available for investment. R1 is the first rate of interest, R2 is the second rate of interest, and then thereafter we have different rates of interest. And when do we add? When there is a compounded increase. And when do we subtract? When there is a discount or let's say there is a loss which is encountered. Similarly here, we would put the same formula as, so let's say amount due after t years, which is the final value, is equal to original value, which is the principal amount due, times of 1 plus minus r into t by 100. Now why do I do it as r into t by 100? Because when we talk about that, the rate r is nothing but the rate of interest per annum. Per annum means for 1 year. So for t years, the total rate of interest becomes how much? R into t by 100, which is why we have put it as amount due after t years is nothing but p times of 1 plus or minus rt by 100. When do we add? When there is an appreciation. And when do we subtract? When there is a depreciation. So in compound interest, the terminology, or when we talk about interest, the terminology changes to profit or premium becomes appreciation, right? Loss or discount becomes depreciation. So when we are talking about interest, we should talk about appreciation or depreciation. Okay. So from here, now if I say, so extending this point 1 as point 1 here only, because I feel that there is not much of a difference here. So the amount due after t years at compound interest, had the rate of interest been the same every year, I'll say what? At upon p will be equal to 1 plus minus r by 100 into 1 plus minus r by 100. And after t years, so we are using the rule of exponents. So few chapters, the knowledge of which is quintessential for this chapter is maybe equations, maybe series, which when I talk about series, I'm talking about arithmetic series and geometric series, ratio proportion, right? Numbers. Now when I say numbers, I'm basically talking about calculations, indices, units digit, how to calculate the square, cube, square root, cube root, etc. That means you would see that this topic is basically an application of quite many topics mixed together. Okay, so now when we say this, here the rate of interest is, we have considered it as rate of interest per annum. But here, if I change it to a different discussion, now what is a different discussion here? The question could have been, now we know that when we are talking about rate of interest, at the same time we need to know that the compounding that is being done. What is compounding? Two or more changes. The compounding that is being done, what is the rate of compounding? That is equally important to know with the rate of interest, right? So let us say if the compounding is done once in every 3 months. If the compounding is done once in every 3 months, that means the entire year has been divided into how many parts? 4 parts of 3 months each. So n now here refers to the number of parts in which this rate of interest per annum has been divided. Please mark the words being used, divided. So in this case, if I say that the compounding is being done at r% per annum, wherein the rate of compounding is once in every 3 months, in that case, that means I need to divide the rate of interest into 4 such parts. Why 4 such parts? Because 3 into 4 makes it equal to 1 year. So which is why we are dividing the rate of interest by n parts, but in that case we are multiplying the exponent by n parts. This expression or formula is very, very important. If the compounding is not behaving in the same rate as the rate of interest or appreciation is behaving. I hope this part is clear. Okay. Now, can I say the rate of interest? Now, before we go ahead, so as discussed that we'll be dividing this session into 2 parts, this video into 2 parts. In the first part, there is a case study approach that I have taken here. And what is the case study approach that I have taken here? And with the help of this case study approach, thereafter it becomes very easy to understand all these points that I have written on the board. Right? So I have assumed that the initial investment, which is the principal amount of investment, is 1000 rupees. The rate of interest is 10% per annum. And then what I have done here is I have drawn a table. Here I have taken the value of t as 0 year, then the first year, second year, third year, fourth year. In short, I am talking about the tth year. Now tth year means I am talking about that year only. And then R is the rate of interest, which we have already taken. I is the interest part that we are talking about. Now this interest can be either compound interest or simple interest. Now and A is the amount due after t years. Mark the words being used. A is the amount due after those many years. That means after t years. And here I have used two different inks. This I have used a black ink, which is RIP, and black ink I am basically using for simple interest. And the blue ink I am basically using for compound interest. Or you can understand it like this. This we are talking about simple interest, and here we are talking about compound interest. Another way to understand the same. So now the table talks about, you would see there would be a very unique observation that you would be doing, and I feel if you are able to draw this chart, the chapter of simple interest and compound interest thereafter becomes very easy to understand. And once you have understood this, you can start attempting the questions or examples thereafter. Okay. So here you would see, if I talk about, there is an amount which is principal amount of 1000 rupees which has been invested for a certain time period, and during the first year, I mean, what is the rate of interest only for the first year, only for the second year, only for the third year? I am talking about a simple rate of interest. So you will see that the rate of interest every year remains the same, right? Second is, now when I am saying rate of interest, the interest will also remain the same every year. I am talking about the simple interest remaining the same. So what is 10% of 1000? 10% is just like saying 1/10 of 1000, which is 100 rupees. So if somebody tells me that, okay, I have invested 1000 rupees at the rate of 10% per annum, what will be the simple interest only for the fifth year? The answer is, the simple interest for the fifth year is the same as the simple interest after 1 year, which is 100 rupees. Or after, I mean, for any nth year or tth year, the simple interest would be the same as the simple interest for after 1 year. Okay, what will be the amount due? Now we know that the amount due after those many years of investment. Now T is those many years of investment. The amount will be nothing but the principal plus the interest part, and here we are talking about the interest as the simple rate of interest. So 1000 plus 100 makes it how much? 1100. So can I say that the simple interest after 1 year was 100 rupees, but the amount after 1 year, so we are basically talking about this length, the amount becomes how much after 1 year? It becomes 1100 rupees. How much does it become after 2 years? After 2 years, it will be 1000 rupees plus the simple interest for 2 years, and the simple interest for 2 years will be nothing but twice the simple interest for 1 year, which is 200 rupees, and the same thereafter. So from here you would observe that simple interest is nothing different from a linear interest. So the moment we use the word linear, I am basically talking about arithmetic series. So simple interest is nothing but arithmetic progression, wherein the common difference remains the same. The common difference. Here common difference is, we are basically talking about the interest remaining the same every year. Now let us focus on the compound interest part. So compound interest, you would see, we know that compound interest is a change on change, appreciation on appreciation, or depreciation on depreciation, or depreciation on appreciation or appreciation on depreciation is nothing but a compounded change. And we know compounded change requires at least two changes. So it is basically interest on interest. So for the first year, you will see that the simple rate of interest and the compounded rate of interest will be 10% only. But thereafter, on this you will be adding another interest. So this is just like saying, for the first year, the compounded interest was 10% only. Next year, you will calculate 10% of 10%. Now, how much is 10% of 10%? 1%. And then you will be adding it to the earlier interest. So 10% plus 1% makes it 11%, which becomes the compounded interest only for the second year. Now for the third year, this becomes this 11%, which is the compound rate of interest for the second year, becomes the principal rate of interest for the third year. So it becomes relative. Now this becomes the principal for this year, this becomes the principal for this year, this becomes the principal for this year, and so on. So from here you will be able to relate. Now when this becomes the interest, the principal rate of interest for the next year, from here you will be able to relate, can I multiply this by 1.1? Yes. Same with 1.1. So this is the unique observation you will get. So which is just like saying common ratio. You're multiplying it by 1.1. So are we given to understand that, as we learnt, that simple interest is nothing but a linear rate of interest. Linear rate of interest means arithmetic interest. Arithmetic interest means arithmetic progression. Okay. At the same time, can we say that compounded interest is nothing but it is an exponential interest, rate of interest, which is just like saying having the same common ratio. The common ratio here is 1.1. So when I said this divided by this, this divided by this, this divided by this, you get the same common ratio. So which is nothing but the geometric series, and geometric series resulting into geometric progression. Progression means to progress, which is appreciation. Okay. So now from here, if somebody tells me what is the total rate of interest after 2 years. So the total rate of interest after 2 years here will be how much at compounded? At compound interest, what will be the total rate of interest after 2 years? So it will be nothing but the first year's interest plus the second year's interest, which is 21%. After 3 years, this plus this plus this, which becomes 33.1%. Right? Okay. Similarly, the compound interest only for we are talking about the compound interest in value. So that becomes 10% for the first year. For the second year only, it becomes how much? 11% of 1000, which is 110. What is the compound interest cumulative after 2 years? So it will be 210 rupees. And the same discussion now you can do for the amount due. So the amount due after 1 year, 1100 rupees. After 2 years, 1210. After 3 years, 1331. After 4 years, 1464.1 rupees. So I would suggest that whatever we have discussed till now in percentages, if you are able to go ahead in the same sequence, you would progress. Right? So today in this video, we have talked about broadly, we have talked about how to take this case study approach, wherein the principal amount that was supposed to be invested is 1000 rupees. And the rate of interest that we have considered here is 10% per annum, and we discussed few formulas and try and relate those formulas with the table, with the values in the table that we have given. Thereon, you will have quite many observations here. So can I say this is nothing but into 1.1? Can I say this is nothing but into 1.1? Of course. So these observations will result into some formulas that I have already put on these boards. So in the next session, we'll be talking about these formulas. Till then, you are expected to go through each and everything that we have discussed, plus whatever we have written on the board. If you feel that something knowledgeable has been discussed today, please give a thumbs up mark to this video. and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. Thank you so much. Until next we meet, goodbye.